start on multiplying and dividing rational expressions. Kind of alter this background a little so it won't fade in and out as much. There we go. It's a lot better. Okay, so to do that, if you remember, if you were just multiplying regular, ordinary, everyday fractions. So let's say if you want to multiply 2 over 3 times 5 over 7. You just multiply your numerators and you multiply your denominator. So you just 10 over 21. Okay, so the exact same thing is going to happen when you multiply rational expressions. You're just going to multiply your numerators and then multiply your denominators. But before you can do that, you have to factor it if it's a polynomial. Okay. So let's just say we'll first start off with just single term examples. So what if we wanted to multiply, let's say for problem A, we'll make it 25x over 2 times 1 over y to the third power. And for problem B, we'll make it negative 7x squared over 5y times 3y to the fifth power over 14x squared. Okay, so starting off with problem A, if we have 25x over, I'm getting ready to put an extra x there for some odd reason, 25x over 2 times 1 over y to the third power. We just multiply our numerators, just 25x times 1. I mean, you don't have to put the times 1 if you don't want to, but it's kind of there. And 2 times y to the third. So you end up with just 25x over 2y to the third. Okay. So for this one, you don't have anything that cancels out or anything like that. So it's pretty straightforward. But for B, go ahead and separate those two. We have negative 7x squared over 5y times 3y to the fifth power over 14x squared. Okay. Now for this one, if you wanted to, you could just multiply it straight across and put it all over one nice little fraction. But first, well, I'll do that on the next step. So you could have negative 7x squared times 3y to the fifth. And if you want, you can put multiplication signs between those two. Or 5 times y times 14 times x squared. And just for visual purposes, I'll put the little multiplication dot in between those. Okay, so now with this one, if you remember that 14 is just 7 times 2. And y to the fifth power, that's just y times y to the fourth power. Okay, and the reason we pick those is because you have a 14 here, but you have a 7 up here that you can cancel out with. Here you have a y down here and a y to the fifth. So if you convert that to a y times y to the fourth, you could cancel them out. Or if you want to cancel out just the regular divide both by y or divide both by 7, you can. This is just another way to do it. Okay, so you have -7. Slide this up a little bit. Seems like it's right up under the glare. Times x squared times 3. And instead of y to the fifth, I'm going to make that times y to the fourth. Just replacing with the same thing. Over 5 times y. And instead of times 14, I'm going to make it times 7 times 2. Times x squared. And I could have made it x times x, but those two x squareds are going to cancel out, so I figured why make it longer. Okay, so we have x squared here and x squared there. Those two cancel out. Remember, they only cancel out when one's in the numerator and one's in the denominator. If they're both in the denominator, they won't cancel out. Okay, so you have a y here and a y there. Those two cancel out. You have a 7 here and a 7 there. Those two cancel out. Okay, so right now we don't have anything else that would cancel out. Okay, but don't forget you still have that negative up there. So here you have -3 times y to the fourth over 5 times 1 times 1 times 2. So 5 times 2 give you 10. Okay, so nothing else cancels out. So that would be our final answer. All right, so any questions on that one? All right, I'll leave that up for a few more seconds. All right, so for our next example, let's say if we wanted to multiply x squared plus x over 3x times 6x over 5x plus 5. Looks better with or without light. Does it fade? It doesn't fade that bad. Does it look better with or without light? That's without. That's with. Without. Okay. This room, sometimes it catches sunlight and sometimes it's darker, so it varies from day to day. All right, so with this one, you don't have anything right off that cancels out. So the first thing you want to do is you want to factor each one of those numerators and denominators. Okay, so you factor all numerators and denominators. Oh, clean that up a little bit. There we go. Okay, so that means for our x squared plus x, we can factor an x out of both of those. So you have x, so x times x will give us our x squared, and x times 1 will give us our x over 3 times x. 6x, you can leave it as 6x or you can make it 3 times 2 so the 3's would cancel out. Either way, it would work, so we'll just leave it as 6 times x for now. So 5x plus 5, you can factor a 5 out of both of those. Okay, so 5 times x will give us our 5x. And 5 times 1 will give us our 5. Okay. Now, if you wanted to, you could go ahead and just make them all across and multiply everything. Or you can cross-cancel it right from that form. Okay, so you don't have to make it all over one fraction. Okay, so here, we have an x plus 1 and x plus 1. Those two cancel out. Here, 3 divided by 3 is 1. 6 divided by 3 is 2. So those two cancel out. Okay. So remember also, you don't have the... Oh, where is it? Make sure nothing... Ah, here it is. I knew something else canceled out. You have an x here and an x there. So those two cancel out. Okay. So the only thing you have left is you have the x here, and you still have that 2 there. So you have 2x over 1 times 1 times 1 is just 1. Oh, and the 5. So you have 5 there. Okay. So that would be your simplified final answer. All right, any questions on that one? All right. Leave that up for a few more seconds. All right, so let's say, oh, anyone's still writing? Oh, leave that up. Still see a few people writing. All right, looks like everyone's done. Okay, so let's say for our next example, we wanted to multiply. Say 3x plus 3 divided by 5x squared. Move that over. Minus 5x times 2x squared plus x minus 3 over 4x squared minus 9. Okay, so just like before, our very first step is we're going to factor out all of our numerators and denominators. So factor all numerators and denominators. Okay, so I'm just going to do those all on the side here. Okay, so our 3x plus 3, we can factor 3 out of both of those. So it's 3. 3 times x will give us 3x. And 3 times 1 would give us our 3. Okay, so that one was pretty straightforward. 5x squared minus 5x. We can factor a 5x out of both of those. 5x times x will give us our 5x squared. 5x times negative 1 will give us our negative 5x. So we put our negative 1 right there. Okay. Now this one, our 2x squared plus x minus 3, it's not a perfect square trinomial, so we're going to have to use the factor by grouping. I mean, not factor by grouping, A times C method, which involves factor by grouping. So A equals 2, B equals 1, and C equals negative 3. Okay, so that means our A times C will end up being 2 times negative 3 which is -6. Okay. So with the A times C method, we have to find two numbers that multiply, bless you, to equal -6. And those same two numbers have to add to equal our B, which is 1. Okay. So for this one, it looks like 3 and -2 should work. So 3 times -2 is -6. 3 plus -2 is +1. Okay, so we knew one had to be positive and one had to be negative since the product is negative. Okay. So that means, for the A times C method, that we replace that middle term with those two values. Okay, so you have 2x squared plus 3x minus 2x minus 3. Okay, so it's still plus 1x, just stretched out. Okay, so now that we have our four terms, we use the factor by grouping. So we make our two smaller terms. And for these two, we can factor out an x. Okay, so x times 2x will give us our 2x squared. So we put our 2x here. And x times 3 would give us our 3x. So we put our plus 3 there. Okay, so now for these two terms, we can factor out a -1. So we go ahead and put that there. -1 times 2x will give us our -2x. So we put our 2x there. And -1 times +3 would give us our -3. So we put our plus 3 there, which gives us exactly what we need, our matching binomials. So we go ahead and factor those two out. So you have 2x plus 3. And you can cross those out if you like. And whatever's left will go into the other parentheses. So you have x minus 1. Okay, so that one's all factored out. So now you have 4x squared minus 9, which if you look at it is a difference of squares. Let's move this up a little bit. There we go. So we can rewrite that as 2x squared minus 3 squared, where our a is equal to 2x and our b is equal to 3. So that means this can factor to become a plus b times a minus b. So that's 2x plus 3 times 2x minus 3. Okay, so we factored all four of our numerators and denominators. Okay, let's finish writing that and then we'll go back up. Alright, so that means that our 3x plus 3 over 5x squared minus 5x times 2x squared plus x minus 3 over 4x squared minus 9, we can rewrite it as 3x plus 3 would just become 3 times x plus 1. Our 5x squared minus 5x is just 5x times x minus 1. Times our 2x squared plus x minus 3. At the end of all that, we knew it was 2x plus 3 times x minus 1. And 4x squared minus 9, since we know that was a difference of squares, is 2x plus 3 and 2x minus 3, all the way at the bottom there. So we have 2x plus 3 times 2x minus 3. Okay, so everything's all factored out. Now once everything's factored out, now we start canceling stuff away. Okay, so we have 2x plus 3 here and 2x plus 3 here. those two can cancel out. We have x minus 1 here and x minus 1 here. Those two can cancel out. Okay, nothing with a 3 and 5 cancels. You don't have any x's that cancel out. So whatever didn't cancel out will be your answer. Okay, in the numerator, the only thing that didn't cancel out is the 3 and the x plus 1. In the denominator, you still have a 5, the x, and the 2x minus 3. So you have 5x times 2x minus 3. Okay, and that would be your answer. All right, any questions on that one? Yes.
Would you combine the terms, like actually multiply it out, or would you leave it in simple terms like that?
You would most of the time leave it like that.
Okay.
It's very rare they'll have you get rid of the parentheses in your final answer when you multiply.
Okay.
Okay. Any other questions? All right, I'll leave that up for a few more seconds. It looks like everyone's done writing. Okay, so let's say for our next example, if we wanted to multiply, say 8x squared minus 8x over x squared plus x minus 56 times 3x squared minus 22x plus 7 over x minus x squared. So just like before, we can't really do anything as long as we don't have any factors. So our first step, we factor all numerators and denominators. Okay, so I'm going to go ahead and just do that right on the side again. And move this over a little bit. Okay, so if we do the 8x squared minus 8x, we can factor an 8x out of both of those. 8x times x would give us our 8x squared. And 8x times negative 1 would give us our negative 8x. So we put that in there. Now for our x squared plus x minus 56, we don't have anything in front of the x squared, so we can just use the basic factoring where our b is equal to 1 and our c is negative 56. Just have to find two numbers that multiply to equal our c, and our same two numbers add to equal our b. Okay, so 8 times 7 is 56. So the bigger number would have to be positive. So we'd make that 8 times negative 7 is negative 56. And 8 plus negative 7 is positive 1. Which means this would just factor to become x plus 8, x minus 7. Okay, so we have that one out the way. So now we have to do 3x squared minus 22x plus 7. Okay. So it's not a perfect square trinomial, so we have to do the a times c method. So we know that a is equal to 3, b is equal to 22, and c is equal to 7. Which means that our a times c is 3 times 7, which is 21. Okay. So now we have to find two numbers that multiply to give us our 21, and those same two numbers add to give us our b in this case, which is negative 22. So two numbers that multiply to equal 21. Those same two numbers add to equal 22. Oh, negative 22. Okay. Now in this case, you can use negative 21 and 1. No, negative 21 and negative 1. So negative 21 times negative 1 is positive 21. And negative 21 plus negative 1 is negative 22. Okay. So for our a times c method, we replace that middle term with those two values. Move this up just a little bit. So that means we now have 3x squared. Instead of minus 22x, we have minus 21x minus 1x. Plus 7. Okay. So now we just factor by grouping. Okay. So we can factor 3x out of both of those. Okay, so 3x times x will give us our 3x squared. And 3x times negative 7 will give us our negative 21x. Okay, so now for this one, we can factor a negative 1 out of both of those. Negative 1 times x will give us our negative 1x. So we put our x in there. And negative 1 times negative 7 would give us our positive 7. So we put our negative 7 in there, which gives us our matching binomials. Exactly what we wanted. So if we go ahead and factor those out, the x minus 7, go ahead and cross those out if you want to, and whatever's left goes into the other polynomial, which is the 3x minus 1. Okay, so that one's factored. So now we have one more, the x minus x squared. Okay, so x minus x squared, if you factor an x out of both of those, x times 1 gives you x, and x times negative x will give you negative x squared. So we have that factored out. Okay, so we have every numerator and denominator all factored out and ready to cancel. All right, leave that up there for a few more seconds, and we'll move back up to the top. All right, so we now have all of our factors, which means that our 8x squared minus 8x over x squared plus x minus 56 times 3x squared minus 22x plus 7 over x minus x squared. And that's going to shut off in about 30 seconds, so I might as well restart.